When you want to multiply polynomial expressions, students generally choose one of two main methods. The first method is, I call it double distribute, but it's not always double. Sometimes it's triple or quadruple. But the idea is you use distributive property to multiply each term by each other term. So I want to multiply each term in the first set of parentheses by each other term in the second set of parentheses. So the first thing I do is x times x is x to the second power. X times a positive 3 is a positive 3x. And then I go ahead and distribute the minus 7. Negative 7 times x is minus 7x. Negative 7 times 3 is negative 21. Once you do that, you look for like terms, or terms that have the same variables and exponents. So I notice I have these two x terms. I should include the minus. I'm going to combine those. 3x minus 7x is negative 4x, and I bring down the other terms. So I bring down the x squared, and I bring down the minus 21, and I'm done. The other way you could have done it is with the box method or the area model. And that method is to set up a box that has room for each term of each parenthesis. So on the top or on the side, I could write x minus 7, and then on the side I would write x plus 3. And bring the sign with the number. Don't stick it in between. And then whatever terms line up, so the x lines up with the x and gives me x squared when I multiply. The 3 lines up with the x and gives me positive 3x. The x lines up with the minus 7. When I multiply them, I get negative 7x. And 3 times negative 7 is negative 21. Then you want to look for like terms within the box and add them together. So don't multiply these, add these. So negative 7x plus 3x will combine to give me negative 4x. So my final answer will be x squared minus 4x minus 21. Two ways to do the same problem. I also want to take a look at maybe one more advanced multiplication problem. And if I wanted to do this problem to expand 2x plus 1 times 6x cubed minus 12x squared plus 8. If you did double distribute, you'd have to distribute the 2x to all the terms, and then also the 1 to all the terms, and then combine like terms, just as we did above. I think once these polynomials start to get a little bigger, the area model, the box method, starts to help you organize your work a little bit more nicely. So set up room to include these 3 terms. I like to do them on top. You could have done a tall skinny box as well, though, put along the side. I'm going to write 6x to the third minus 12x squared plus 8 along the top. And then along the side, I'll write 2x and plus 1. So I'm separating out all the terms. And then I'm just going to multiply. So 2x and 6x to the third, when I multiply them, gives me 12x to the 4th power. And then if I keep going to the right, 2x times negative 12x squared, I get negative 24. I'm going to multiply the coefficients, and then I multiply the x's. I get x to the third. I'm just going to add the exponents. There's really an exponent of 1 there. You could add that if you wanted. Just put it in there to remind yourself. 2x times 8 is positive 16x. 1 times 6x to the third is 6x to the third. 1 times negative 12x squared is negative 12x squared. 1 times 8 is positive 8. Okay, now we're just going to locate and combine our like terms. So I'm looking for anything with the same variables and exponents. So I've got this x cubed term that combines with this x cubed term. And it looks like those are my only like terms to combine. So negative 24 plus 6. This is a positive 6x to the third. So I like to write it in descending exponent order. I like to put my biggest exponent term first. So 12x to the fourth is my biggest exponent term. And then I'm going to combine this 6x to the third minus 24, which is negative 18x to the third power. Now I'm going to write my next highest exponent, which would be minus 12x to the second, followed by plus 16x, followed by plus 8. And I'm done.